Good evening, everyone, and a very warm welcome to Workshop 2 of Innovate with Ballerina 2025. It's so inspiring to see your continued enthusiasm and energy as we dive deeper into our journey with the Ballerina programming language. As a quick reminder, Innovate with Ballerina is an innovative idea hackathon designed to empower university students like you to build impactful, real world solutions using Ballerina, a language created for modern integration and development. This initiative is proudly organized by the IEEE Student Branch together with the IEEE Computer Society Student Branch chapter of the University of Moratuwa. And once again, we express our sincere gratitude to WSO2, the pioneering force behind Ballerina, for powering this entire initiative. Their commitment to open source excellence and developer empowerment continues to fuel innovation across the globe, and your participation is a part of that wave of change. Before we get started with today's proceedings, let me briefly share what's in store for you. Today, we'll be exploring the AI capabilities in the Ballerina programming language, discovering how it can be used to create powerful data-driven applications. By the end of this session, you'll have a solid understanding of how to bring AI-powered features into your Ballerina projects. Guiding us through this exciting topic is Mr. Sasindu Alahakoon, Senior Software Engineer at WSO2. Mr. Sasindu will walk us through the practical demonstrations and share insights from real-world scenarios showing how AI and Ballerina can work together to create impactful solutions. So let's give a warm welcome to Mr. Sasindu Alahakoon and hand things over to him. Over to you.
Hi everyone. So thank you Sanaya for the introduction. So hope you all can see my screen. Okay. Okay. I'll start. So hello everyone. I'm Sasindu Alahakoon, Senior Software Engineer at WSO2. So today I'm going to explore about Ballerina with AI capabilities using real world scenarios and core concepts in AI. So in this session, I will first introduce about a brief introduction about Ballerina and then AI, then core concepts about AI. Then I will explain how we can use AI to develop Ballerina development, and then how we can use Ballerina to build AI applications. And then I will do a live demonstration about AI applications with Ballerina. Okay, so what is Ballerina? You may know about Ballerina because you participated into the several sessions before this. So I will give a brief description. So Ballerina is an open source cloud native programming language optimized for integration. So we have a rich ecosystem of network protocols and data formats and connectors. So we have a very rich ecosystem like HTTP connectors, HTTP library, GraphQL library, WebSocket, and Gmail, Google Calendar, GitHub, so Google Sheets. So like that, there are so many libraries we have to integrate your systems each other and build the integration. So next, what is AI? So AI is the domain of the field of the computer science that focused on creating machines that can simulate humans. Simulate the human intelligence. So like as example of a self-driving car, self-driving cars, right? Self-driving cars use AI to see the surround of the car. So it use machine learning algorithms, vision capabilities to detect the cars, roadblocks, and traffic rules to navigate safely. And also virtual assistants like Google Assistant, Siri, those are also applications of AI. They can understand our command, right? And they can also act according to that. As example, setting an alarm, or send in an email or search something or something like that. Okay, now let's dive into some core concepts of AI. So when we discussing about the AI domain, so like as a human, so what is our so our main ability to so our ability to communicate each other and understand the context through our language. So those concepts are not studied like not resolved by the AI for a decade. So AI, in previous decades, AI cannot understand human language and understand the context of a simple sentence or an English thing. So by time in evolving, AI understand this human language through NLP and those kind of things. And currently, it will understand the human language efficiently using the large language models. So if we discuss about the large language models, it's a subset of AI and it is specialized in understanding and generate human language. So it can answering questions, it can summarize documents, it can generating code. So as example, you all know ChatGPT, right? ChatGPT is the popular LLM, I think. So I think all of you use the ChatGPT to do the programming and those stuff. And also there are several LLMs like Google Gemini, Mistral, and Show OpenAI, and also Llama and DeepSeek like that. So if we discuss about LLM, you would think LLM can do a lot of things, right? So as an example, if you don't know front-end application React or something like that, you can generate those using ChatGPT, right? LLMs. And if you want to summarize something or do some assignments, you can do using LLM, ChatGPT or something like that. But LLM also contains roadblocks. Like LLM contains issues. So let's discuss those things in this slide. So roadblocks of using standalone LLMs in real worlds are, the first one is the knowledge cutoff problem. That means you already know that the LLMs are trained up to some date, right? So now if you go to the ChatGPT and ask, so what is your last train date? It will answer train date is June of 2024, right? So after that date, after let's say July in 2024, it don't know the information, right? So that is knowledge cutoff problem. It does not have up-to-date information. And the second one is the hallucination problem. So that means LLMs make up facts when they don't know the answer. You may experience that in, I think. So if you ask something that LLM doesn't know, it does not say it doesn't know that, right? What it does is it give a fake response. So like if we haven't the idea about the response, we will think that it is correct. So that's the issue in a standalone LLM application. So and also the third one is LLMs can just talk in, right? It cannot take action. So as an example, if you go to the ChatGPT and tell the ChatGPT that please create a GitHub issue for me with this content, so it will give you the steps to create that. So it will tell you that go to github.com and so on and like that, but it cannot execute that, right? It cannot create the issue. So LLM cannot take actions. That's also a roadblock of the standalone LLM application. So mitigate those roadblocks. There are few AI application patterns and concepts are introduced. So there are three main things. So first one is retrieval augmented generation, named as RAG. And second one is agents and tools. And third one is MCP, Model Context Protocol. So I will explain these things in the upcoming slides. So retrieval augmented generation RAG is a concept, is a AI application pattern that makes LLM smarter by connecting it to a factual knowledge base. So yeah, if you don't familiar with that, you will not understand like that. So I will explain like this. It is like a clever, intelligent student facing exam with open book exam. The intelligent student facing the exam with open book. So student already know a lot of things, right? Because he's clever. He know a lot of context and a lot of educational things. And also, since he is facing an open book exam, he has the access to a knowledge base, right? If there's a question he don't know, he can check the notes and check the answer, get the answer, right? So retrieval augmented generation is something like that. So what we do is we get the LLM and connect it into a trusted factual knowledge base. So now LLM have a knowledge base. So when we ask a question about some domain, so it does not need to answer by its own or a trained data, only using the trained data. He now have the knowledge base. He can go to the knowledge base and getting the knowledge, like searching the knowledge from the knowledge base and right. So this will very helpful when we developing LLM AI applications for our companies. So as an example, assume WSO2 want to create a chatbot application or AI application that like there are so many HR policies and there are so many policies in a company, right? So we need to add a chatbot that I need to, when I ask something about my company policies, it need to reply me. Like if I ask how many leaves, how many annual leaves I have, it need to reply me. So something like that. So if I need to create a application like that, normal standalone LLM cannot do that, right? Because it doesn't know about WSO2. It know about WSO2, but it not trained with WSO2 policies, right? So we need to get a LLM and plug with a knowledge base that contains the WSO2 policies and HR policies and those policies into the LLM. So LLM plus knowledge base will give the better result for that certain scenario. So RAG is something like that. So yeah, so like in the slide, LLM knows a lot of about the internet, but it knows nothing about the company's specific information. So that is why we plugged a knowledge base into the LLM in order to retrieve information that is specific to the company. And also we can think it like this. So if we consider organization domains like law, financial, and medical. So if some application give wrong answers in those domains, that is dangerous, right? So like it can be unrecoverable problems. So for those domains also we need to make our application to provide trusted and correct answers. For those scenarios also it's better we can use a RAG. RAG means LLM with a trusted knowledge base to force answer on a specific facts retrieved from a trusted knowledge base. So that is the concept behind RAG. So let's see how RAG resolve these problems. So RAG, the knowledge cutoff problem will solve by RAGs because RAG contain a knowledge base. So LLM can anytime go to the knowledge, when user ask thing, LLM can go to the knowledge base and answer, right? So it will not use its own trained data. So if the knowledge base is up to date, then LLM is also up to date. So the hallucination problem, so it does not need to make up facts, right? LLMs make up facts then when they don't know the answer. But if we have the knowledge base and it contains the knowledge that we need to answer, it can go to the knowledge base and get the answer. It will not resolve this, take action. Let's see in the future. Okay, that is the main idea behind the RAG. So let's see the RAG architecture now. So this is the RAG architecture. So this part is for a normal LLM. So what normal LLM does is when user give a prompt, it's like you type in something in the chat GPT. What it does is the prompt will send to the LLM and LLM will process that prompt with their trained knowledge, trained data, and it will give a response. That is what normally happens, right? Is the upper flow. So if you have a RAG system, what happens is, so user give a prompt and it didn't go to the LLM directly. What happened is it go to a component called retriever. This is a component. So it go to it. So there's a component called retriever, and what it does is it take the user query and then it check the knowledge base against this query and retrieve the relevant documents to answer the user prompt. As example, if you consider this knowledge base contains leave policy document for leave policies, and there's a document for some other policies like that, and user asks something regarding to the leaves, what retriever does is get the documents that relevant to the user query, that means leave. So it will get the relevant documents for leaves. So something like that. So it will retrieve the relevant knowledge for the user query. Then what happened is it created something called augmented prompt. That means it created a prompt by combining those gathered relevant documents, those gathered knowledge with the user query, and give that to the LLM, and then LLM will give the response. So if we consider this example, this is what user asked. So assume that this knowledge base contains so assume that this system is a chat application for a specific company called Innovate Lanka in here. So what it does is, like I said, it has some policy documents. It create a chatbot application to if employee need to ask something regarding the policy document, they can chat in the chatbot and get the answers. That is their system. So if user ask this question, what happen is, so this retriever component will take the user query and search the knowledge base and get the relevant documents and create this augmented prompt. This is the sample augmented prompt. So it is not just have this user query, and also it has the context, right? Context means the relevant parts in the knowledge base for the user query. So now it has a context section 7.4 used, unused, and value. There are so many like information related to the annual use. So, and also it contains the user questions. So this complete prompt, this called as the augmented prompt, this complete prompt will send to the LLM. So now the LLM does not know about the Innovate Lanka, right? ChatGPT or something like does not know about a specific company policy. But since the augmented prompt contain the context and the like a rules or something policies regarding the annual leave, now LLM can understand how to answer this question, right? Because it can now have the context. So now LLM will process the augmented prompt and return the response. So that is the basic idea behind the RAG. I hope you can get the idea about RAG application. If you have question, ask. Yeah, so that's the basic idea about RAG. So now let's go to the next slide. So if we build a RAG application, so what we need first, we need LLM and we need the knowledge base, right? This component, we need this component. So let's see how we can build that component, knowledge base component. So that is called RAG ingestion. So building the knowledge base for RAG. So what we do in here is, so we have data source. It's like I said, HR policy document or a leave policy document as a .md file or a text file or something like that. So we have data sources written in natural language, written in English. So this is that. So if you remember correctly, so in here what we do is this retriever check this knowledge base against the user query, right? So like yes, so in here before I will explain this and go to that part later. So let's focus only on the building the knowledge base for that. So I have the data source, policy document, text files, and empty files. So what I do is, so I will first split into chunks. So I will split the document into chunks. The natural language document into chunks. The idea behind this chunking, because there's a concept called context window in LLM. Context window means the maximum number of text that LLM can process. So as example, if we take it as X, if the character number is larger than X, it cannot handle that. So because of that, we need to split our data sources. Otherwise, if our data sources are larger than the context window, it will crash or give an error. So because of that, we split our data sources into chunks. Then now we have a chunks of our data sources. Now the important part came into action. So now we have the natural language resources. So, but LLMs or any machine learning algorithms cannot understand English directly, right? What happens is we need to represent it as a numerical. We need to convert it into a numerical representation. So what we do is we generate embeddings for these resource chunks. For that, we use an embedding model provider, and we generate embeddings and save that in a database. In here, it is a vector database. So that is how we build the knowledge base. Take the data source, split it into chunks, and then generate embeddings. That means convert the natural language into a numerical representation. Then we store in a vector database. So that is how we build this part. And important to understand that if our data sources are not changed frequently, we don't need to build the knowledge base again and again, right? So if we have, let's say 100 policy documents for various reasons, policy and other documents, if the company policies are not changed rapidly or frequently, we don't need to update the knowledge base, right? So if it is updated, we need to ingest those documents again to the vector database in the similar process. Otherwise, we don't need to do that. So yeah, then the query part, I will explain the query part. So now I develop the knowledge base. So now user give a query. A user add a query to my RAG application. So now, like I said previously, retriever want to retrieve the relevant chunks from the knowledge base for the user query, right? For that, this is the flow, what happened in here. I will explain. So first, we will embed the user query using the same embedding model we used in here. Because we need to convert the user query into a mathematical representation to compare. So we generate the embeddings using the user query. Then what we do is, now we have the embedding vectors of the user query. And in our vector database, we have the embedding vectors for our chunks that represent the data sources. So now we will retrieve the similar documents using comparing the embedding vectors. So now after that, now we have the relevant chunks, relevant data source chunks that is relevant for our user query, like in here, relevant document for answering the user prompt. So it getting after this step, retrieving similar documents. So after that, what we do is we augmented the user query with the relevant documents, and then we will send it to the LLM. Hope you got idea about what happened in the RAG architecture. So, okay. So now let's go to this slide. So I think now you can get understand about up-to-date data because it has a knowledge base and factual knowledge. An example for RAG applications is, like I said, about there's a LLM application or AI application or a chatbot about company policies, websites, internal documents, something like this. Those are the application we can use, right? So in your hackathon, if you are planning to do a project regarding to those things, like something like those RAG related application, you can use this because this is like a RAG is a well-known AI application package. Okay, we go to the AI agent. So AI agent, like in standalone LLM application, I said that LLM cannot do actions, right? Like I said, cannot create a GitHub issues for you. It will give you the steps, that's all. So AI agents come to the action to solve that problem. So AI AI agent can if you give a problem to the AI agent, it can think the steps and execute that, and get the result and execute again and get the result and execute again. Like that, it can perform chain of actions in order to do some kind of a use case. So I will describe that again. Before that, I will tell you what is a tool. Tool is also a concept in AI. Tool means a specific function or a capability. It's like this. LLM is like our brain. Like we can think, we can intelligently think, and like we can understand things, and we can get to know what we need to do. We can know what to do, but we cannot do without the brain, with the only the brain, right? We need hands or legs, something like. Tools are something like that. So LLM is the brain and tool is the hand. So, that is the simple example for that. So like that, tool is a specific function or capability due to an LLM to perform a task. So as example, the send email is a tool that you can access to email client and send the emails. So and also there can be calculator tools that can be add integers, divide, like that. There can be functions we can use as tools in order to perform an action. I will explain more about tools when we do the demonstration. Then you will understand how these tools come into the picture. So next, I will explain what is an agent. So agent is something like LLM prompt to think strategically. Like agent has a brain, memory, and tools to interact with the world. It's like a agent has the brain and memory and tools like in human context, it's like hands, tools to interact with the world. So the brain of the LLM uses tools to perform actions, and as the brain has the core reasoning engine, and also agent has the memory to maintain context and learn from the interaction. So agent will store the previous interactions in the memory for future tasks as well. Yeah, that is the basic thing I need to talk about the agent. And also I can say the agent is the complete autonomous system that combines everything. It's an LLM that has been specifically prompted to think and solve multi-step problems. Next, I will explain about the Model Context Protocol, MCP. This is also a hot topic in current AI domain. So I will not going to explain deeply about this MCP. If you interest to learn this, you can, there's a course in deeplearning.ai. It explain A to Z. You can use that. So I will give you a brief description about the MCP. So MCP is a something standardized how a application interact with the external system. As an example, if you take an agent, AI agent, so AI agent needs tool to execute things, right? So some of tools are inside the in the same code base. In a local code base, we have tools, but some of tools are in external servers that it cannot directly access. It cannot be accessed directly to us. For that, there's a protocol called MCP. So we can create MCP client in a host application, and then MCP client is responsible for calling an MCP server, and the MCP server will provide us the external tools that required for our AI agent. So MCP can use to get our external tools, external resources, those things like that. Okay, those are the core concepts in AI. So I will go to this slide again. So for agent and tools, so this is I will tell the example. So the booking the meeting, sending an email, updating a customer record, those are the those are some kind of example use cases of agents and tools. So if like I said previously, if you are planning to do your hackathon projects with those kind of tasks, if you have something similar task, you can use AI agent to perform that. So I will explain in the programming part in the demonstration. Okay, now we discuss about the RAG and AI agents and MCP. So let's dive into Ballerina, Ballerina and AI applications. So first I will explain AI for Ballerina. That means how we can use AI to develop Ballerina programs and like how we can use AI to help Ballerina developers. Okay. So we have a copilot, it named as Ballerina Copilot. So it is written in Ballerina itself. So we can use Ballerina Copilot to code generate using natural language. So this will very helpful you to when you're doing the projects. Like you don't need to build all the things from the scratch. So Ballerina Copilot will help you to build things. You just need to give the prompt in natural language and it will give you the program. And also it is capable for data mapping using AI. So mapping one record type to another record type using AI. And also you can use Ballerina Copilot to ask about Ballerina concepts, libraries, capabilities, like if you want to know about Ballerina GraphQL, how to convert HTTP GET resource into a GraphQL, like those things you can ask about Ballerina, ask with Ballerina Copilot and get to know, like it will explain how to do that like that. I will show those things on the demo as well. And also you can generate tests using natural language. So in your for the components in your program, for the services resources in your program, you can generate tests using Ballerina Copilot. So we will like seamlessly the development cycle. We can use Ballerina Copilot to like do these things very easily. Yeah, these are the images of the Ballerina Copilot. I will show you in the demonstration as well. Okay, the next one I'm going to show is Ballerina for AI. So this means uh, developing AI-based applications using Ballerina. Okay, so we have rich set of connectors, Ballerina AI connectors in our Ballerina Central. So we support various different model providers such as OpenAI, Azure OpenAI, Anthropic, DeepSeek, Mistral, Olama, like that. I think you surely know about OpenAI because ChatGPT is from OpenAI, and also DeepSeek uh, and Anthropic, the Claude LLM. The Claude, you may know about Claude. It is from Anthropic, and there are some other Mistral and Olama as well. So this is the screenshot of our Ballerina Central connector list. So, and also I would like to say there's another model provider called WSO2 default model provider. So we developed that you can use to test all our Ballerina features entirely free. So you know that if you want to test a OpenAI, if you want to test a AI application or something like that, you need to create a token from OpenAI and you have to pay for the token and use that, right? So in Ballerina, what we do is we we create a model provider called WSO default model provider, so you can test all the features entirely free. So if you go to the production or if you are doing if you do something monetary things, you can use a different model provider because this is entirely free with rate limiting control. But if you want to test all the Ballerina features or if you want to add your programs into your hackathon project, you can use this default model provider. I will show about the default model provider in the demonstration. Okay, now let's see how we can use Ballerina to develop AI applications. So first one I'm going to describe is direct LLM calls with Ballerina. So what I mean by direct LLM calls is simple stateless LLM calls. where conversation history is not relevant. So we can do two, like in our model providers, we have two APIs. First one called chat API. The chat API is designed for conversational history required use cases. That means I said something to LLM and model also said something to me, and I do again, and model tell me something again. Like that, there's a conversation requirements. That API called chat, and we have another API called generate. That is for direct LLM calls. For that means for simple use cases where the chat histories do not relevant. So in our generate API, the direct LLM call API, we automatically struct the LLM response to the expected type of the user. I will describe that in the next slide. So this is a sample program that we can use to call LLMs directly. In this example, we use the WSO default model provider. So I will explain the code. So in here, okay, in here, the code, I have defined two types, blog and review. So blog to present a blog, the article, medium article, something like that. And review is something like a person review the blog article and give marks for that, something like that. It represent by the review. In the review record contains suggested category and rating. Suggested category means the blog is relevant to one of these 5 categories. So these are the two defined records for my use cases. So now I have defined a function called review block, and it accepts a parameter of type block. That means it accepts a block and it returns a review type. So in order to do the direct LLM call, first we need to initiate a model provider. Model, right? We need to initiate a model. So we initiate the WSO2 default model provider in here. A type name as WSO2 model provider. And in our Ballerina AI module, we have util function called get default model provider. It will return the WSO2 model provider. So now our model is, we initiate our model. Now we need to do the direct LLM call. For that, we use the generate API. API means generate function. So this arrow function means we are doing a remote call. This is through the internet, right? We call the LLMs through the internet. So this is a remote call syntax. So we call the generate API, generate function. So in here, but we give the prompt. In here, the prompt is you are an expert content reviewer, blog site, and we said your tasks are suggest suitable category and rate the blog post to scale 1 to 10. So this is the prompt we give to the LLM. So when you write in prompt, there are a lot of prompt engineering techniques. You can learn them from the resources. So I will give you a very brief things since it was there in the example. So it is better if you can, like in the first line, you can see that you are an expert content reviewer for a blog site that categorized, like we said to LLM that you are expert in this domain. So it will help to get a better accuracy in LLM result, because we tell LLM that you are an expert in this, like that. And also we clearly define what we need. And finally, we provide the content of the blog, the title of the blog and the content of the blog. So then what happens is LLM evaluate this blog and return the result. In Ballerina, the return result from the LLM will automatically map to the left-hand type, the expected type in the left hand. Since this is a record with 2 fields, this response from the LLM will directly map to the record. So if you provide, when you try this, you can copy and paste this code and try. So if you provide something string in here, this result will be a string. If you provide int, this result will be int. If you add some field to here and add this field, it will also result is something like that, according to that structure. So Ballerina has that capability to convert the LLM response in order according to the user expected type. Okay, this is also a direct call LLM example, but this use the not the WSO2 default model provided. This use the OpenAI model. So for that, we need to import our Ballerina's OpenAI model. So this is our syntax AI model name AI.OpenAI. If you need Azure, AI.Azure. If you need DeepSeek, AI.DeepSeek. So you need to import that. Others are same. The initiate model initialization part is different. In here, what we do is this we define the type, and in the new we need to provide the API key for the OpenAI, and we need to define the model. In here, I use the GPT-4 mini. If you need to use GPT-4 another model, you can use that also, and others are same. So that is how we use Ballerina to directly call the LLMs using the generate API. If you want to do a conversational based use case, you can use the chat API. There's an API called chat. Okay, now this is something interesting. So LLMs can understand that now in the current state, LLM can understand images, and also some LLMs can generate images as well. So, and also in OpenAI model, especially they can understand audio and output audio, and also understand about PDF files. So those multimodal concepts are now embedded into the LLM models. So now this Ballerina also support multimodal prompts inside the LLM calls. So this is example of we are adding an image into the LLM prompt. So this use case is this program is about an insurance company service. So what happens is if user post an insurance claim, the user can post insurance claim with a description and an image. As example, if there's a car accident or something like that, he can get an image and upload that into this resource. So what happens is internally we get the image and the description, and we put that into the LLM prompt and tell LLM to give a summary like that. So what we do is we have a type called image document in the AI module. We get the image as a byte array and initiate the AI image document using that byte array, and we give that to the LLM prompt. Then internally LLM prompt will understand the image and give the response according to that. And also the interesting part in here is we abstract out all of these things. Like if you change the model provided as OpenAI in here, in this line, the rest of code is same. Like you don't need to define another record for OpenAI. It is all are same. Like if you need to change the model, you just need to change this line. That's all. So in Ballerina, we support these multimodal concepts in the AI prompts using very simplicity, and also it's very generalized for all model providers. Yeah, that is all about the direct LLM calls with Ballerina. So it's like a simple LLM call. So in your hackathon projects also, if you have something like reviewing blogs or let's say summarizing or something that understanding or rating or something like that, you can use this direct LLM course for your hackathon programs. Okay, now in the Ballerina for AI part, the second part I'm going to discuss is building RAG applications with Ballerina. So I'm going to do a demo for this, so you will understand how we can do this in Ballerina. So if I explain, so Ballerina has like very simple, like very minimum number of codes to we need very minimum number of codes to implement a RAG system in Ballerina. So it has automated document chunking, vector store creation, seamless data ingestions, intelligent context retrieval. For all of these, we have functions. Like you just need to give the relevant context for that, and it will automatically do all the things and integrate the RAG application into our system. So I will explain those things in the demonstration. Okay. So the next part is building AI agents with Ballerina. I will also do a demo for this also. So, uh, when I explain the AI agents, I told you something called tool, right? So agents need tools to execute some things. So in Ballerina, we have rich connector store. Like we have almost all connectors in our Ballerina Central. Like in the right hand side, you can see we have Gmail, calendar, and Slack like that. So we can use those capabilities in the our connectors to perform as tools for agents. Like if you need to send an email through an agent, you can use Ballerina Gmail connector, and it contains a resource called send email. So you can use that as a tool. So if you're using Ballerina to build agent, you can have inbuilt uh, a lot of number of connectors. Uh, so yeah, that is the tool part. And also in Ballerina, we have two type of agents. So first one is a chat agent. So I'm going to do a demo today using this chat agent. So this chat agent is this chat agent exposed through HTTP endpoints as REST API. So this is like ideal for a chatbot application, chatbot experience. So like I said, if you have some kind of policy document or some kind of information document, so you can use that as a data source, and using the RAG concepts, you can store that in the vector database and create a chat agent, and then you can chat with that agent and like asking questions and get result like that. And also you can create a AI agent that can like send emails if you want to know what is your email summary, send emails, and if you want to create a calendar event through a chat, this chat agent is the ideal way to do that. And the second one is inline agent. This is different than chat agent. This is embedded within a service logic. That the chat agent is a HTTP service that exposes as a chatbot experience. Like I mean, I will show in the demonstration. It will expose as a chatbot. So it will get a UI and you can chat with the chat agent. But inline agent, what do is it is embedded within the service logic. So when the backend is running, the inline agent will invoke programmatically and do the task that is need to do. So that is ideal for automation things. So when you are creating the integration to execute each building blocks, this inline agent will helpful, and chat agent will helpful for chatbot like experience. Okay, that's it for the Ballerina for AI. Okay, now we can do the demonstration. So I will first explore you about the Ballerina Copilot. Mm, Will switch my screens now. Switch my screen. Okay, hope you can see the screen now. The VS Code. Okay. So now first I will demonstrate you about the AI for Ballerina part. First of all, I hit the slide. I will demonstrate this part. Mhm. Okay, so I will go to the main WordBell file. Initially, this file is empty. So this is my Ballerina Copilot. So first of all, we are developing a product called BI using Ballerina. It's a low code based product. It is mostly targeted for the integration developers. So Ballerina is for pro code developers. Like if you like to code things like write codes like Java. So for BI, what we do is we do a visual program using the visual diagrams and like drag and drops like that. So that is our product name BI. It's a low code platform. So BI and Ballerina has the same copilot called BI Copilot. We can use that for generate the pro code as well. So first I need to log into the BI Copilot. So now BI Copilot is there. So I can chat with this. In here, you can see that there are several commands slash code, slash test, slash data map, data map like that. So this slash code is this command is used to generate code using the natural language. So if you have use case, you can generate code using this command. If you need to generate test, you can use this. And if you need to map one record type to another record type using AI, intelligently you need to map, you can use this one, and so on. You can use these commands, and this slash ask thing you can use to know about the Ballerina concepts, libraries, and best practices, and like that. Like our documentation, like if you are like lazy to read the documentation in the website, you can use this slash ask command and get to know about the things using the Ballerina Copilot. So that's why we have subset of commands in here. So you can use those things depending on your application when you are developing your hackathon project. So for my thing, I will start with the slash code. So it will, I will show you without this sub command. I will just type, hello, give me a sample hello world test service. It will take some time because it need to go it internally. This is Anthropic Cloud, so it need to do a remote call to generate the integration, generate the code. So now it generated the code. I can review this like this, and I can add to integration by simply click this button. Now it is add to the code, right? So it will give me a HTTP resource, HTTP service which contains two resources that will return hello world. Like it will give you as a path variable and interpolate that also. Okay, that is. So now let's do some real world application. So I will remove this. We can clear the chat history using this clear button as well. So I will type like I need a sample to do application as a REST service. So it will first explain you right what he think and what he going to do, and then it will generate in the integration for the use case. So this is the plan of the Ballerina Copilot. It try to give 5 resources: retrieve all to do items, retrieve specific to do items, like that. It will tell you what he going to do, and then it will generate the code, and it contains 3 types: to do request and to do response, as I expected. And also it contain a resource Ballerina service with several resource functions. So now I can add to the integration. Okay, now it is completed. So I created the sample to do application within 10 seconds, right? So that is how our Ballerina Copilot works. So you can also use this into a project. So now I can see this to do store is a map. right? Map is, that means in-memory database, in-memory store. So I don't like to use a in-memory store. I need a database. So what I do, what I tell is, I need to store to-dos in MySQL database. In MySQL. So I will hope it will convert the in-memory database into MySQL database. Yeah, it will say modify the to-do application to use MySQL database for persistent storage instead of in-memory storage. So it gather my idea, and it will show database operation he going to create, and also database configuration, MySQL client setup, those things also inside here. And it created the code for me. Yeah, in here you can see that there's an error in the code because sometimes LLM like give wrong answers, right? So we can like retry this thing again and create the code we want to know. So if there's syntax error or something like that, we disable this auto integration button for the security of the code, because if there's error, that is syntax error, it will uh, lead to problems. So you can also review this code in here and just copy paste in here, or else you can retry and say this the above code contains errors, please fix and give the correct code, like that. So it will generate a code again. So that is how we can, like, it's like a chatbot for Ballerina. It's actually a chatbot to Ballerina that can generate codes. It is generating. So yeah, it will understand what is the errors in there, and then it will generate a code. Now we can add that into the code. It's like it doesn't got the idea of me, the previous one. So I need to do that again. While this code is generating, yeah, you can see the already code that Copilot generated. Like it is the resource function get post for the creating or sending something, and get for getting fetching the details, put for update, and delete for deleting things. So seems like it adhered to best practices in Ballerina. uh, and it also add comments. Like if you do not want add comments, you can, in the instruction you can say I don't need comments, like that. So if you need this as public function, you can also set in the prompt, I need only the public functions, like that. So this is how we can use our Ballerina Copilot for uh, to build our integration without doing from the scratch, but from the natural language. Uh, it's yes, now it's take that correctly. You can see that it use SQL database and SQL queries to do the action. So like I expected. So that is how you can update the existing code to your need using the Ballerina Copilot. And you can, like I said, you can interact with him. I have errors, please fix that. I don't need this resource function. It will update and give the integration for you. You just need to click the add to integration button. If you need to revert, you can revert also. If you can add, you can click the add button also. Okay, so that's all for the generating code. Now I will show you the test generation part. So if you click the slash test for the code generation, you can also use this also. I use the just type. If you have the use case, you need this also. I need to do application, something like that. For the now I will showcase the test generation. If you click the test, you can see that generate test for service name, generate test for resource. So I will add a test for the service name of this. The service name is API v1, the path, right? So I will, yeah, in here it will show so like this. So I will add test for this using the Ballerina Copilot. So now it will give you a test plan for the to-do API service. It will give you the whole scenarios like happy paths, edge cases, error path. You can see that this error path, this happy path, and it will think and let you know what you're going to do. Like this. Scenario 1 for the get, and it's a happy path test. And scenario 1, 2 is a error path test for get, triggering database query failure, like that. So it will generating test for this, and after test creation you can just click the add to integration button to add the test for your code base. That is how we generate tests using natural language using Ballerina Copilot. We need to wait a couple of minutes while it's generating. It's a generated test for the service, and it's analyzed the generated test for the potential issues, and then it's refining the test. Like it done it doing all the things that a human need to do. Uh, so it's yeah. Finally, tests are created now. You can see the tests in the test directory like this. You can see it explains in the comments. This error path. Sorry, this is happy path. And this is error path, non-existing ID error, and it give the error messages, assertion the error messages, like that. It will generate a bunch of tests for all the resources for both happy path, error path, and edge cases. Okay. Now I will demonstrate to you the slash ask command. In the ask command, you can use ask anything about the Ballerina Copilot regarding the Ballerina programming language. I will ask, can you explain about Ballerina GraphQL library? So it will use the Ballerina sources in the internet, our learn pages, our other documentation pages, and obtain the user query and find the similar matches for that and give you the solution. So it will describe the answer like this. Like it will tell you about the GraphQL client and the APIs in the GraphQL client, execute type, deprecated API, and this is an additional utility function. And this is how example client configuration, how we can create a client. And also give a reference about if you want to learn about more, you can use this link to get the details. Okay, that's all for Ballerina Copilot. You can use this when you developing the Ballerina projects to build things easy. Okay, now I will remove these files. So I will delete these files. I'm going to do the next demo. I will remove the test file. Okay, now almost all the files are empty. I will keep this configuration file as it is because this configuration file I need for the demo. Okay. Remove the source. Okay, now let's start to our second demo. In this part, I will do a RAG application using Ballerina. I will develop RAG applications now. RAG application now. So, if you remember, RAG flow is something like this, right? So it does not respond to the LLM directly. Before that, it will retrieve the relevant documents and augment it into the prompt and give to the LLM and get the response. That is the flow. So when I am explaining this, I told you that we need to first develop this knowledge base. So this is the flow for that, called RAG ingestion. So building the knowledge base for RAG. So for that, we need a data source and we need to split into chunks and generate embedding and store in the vector database. For my demo, I will use Pinecone provider as the vector database. And as the embedding model, I use the WSO2 default embedding model. We provide that entirely free for the users who can test our features. I will explain you how to do that. So first, what I do is I define this data source. I need a data source for this. So my application for this demo is, my scenario for this demo is a company has a HR policy document. We'll update this. So there's a company and it can called Megaport. The name is Megaport. I generated from this chat GPT actually this document. So the company called Megaport has a HR policy document. So this company need to create a AI application. So that application need to read this HR policy document and answer the queries that users ask regarding this policy document. It's a kind of a RAG application. The data source is this HR policy document. That is the thing. So I define this data source in here, this part. Then I need to split read and split into chunks. So I will do that next. So in order to do that, I will define a main function in Ballerina. So then first I will read the document. I import the Ballerina IO module and file read string function. And this read this document. Okay, now then assign this into a variable called content. I just simply throw these errors using the check keywords without handling those explicitly. Now I read the data source. Now I need to split that into chunks. So for that, we provided in our AI library. I need to import the AI module Ballerina. In our AI module, we have a function to chunk document recursively. So I will use this function to chunks the splitting document into chunks, this part. So if I go to the definition of that function, it will say provide the function to recursively chunk a text document using a configurable strategy. So there are several ways of chunking documents. The recursive chunking is a one part of that. So what it does is it accepts a max chunk size and a max overlap size. Max overlap size means, yeah, like what we're going to do is we split the document, right? So when we split in documents, the nearby chunks contains an over which chunks uh, to have nearby chunks have some overlap region. So same content is overlap in the adjacent chunks. That is our strategy in here. So in here the max overlap size is 40. That means there are maximum number of characters that overlap in the adjacent chunks, and the max chunk size is the maximum number of characters that can have inside the chunk, the one chunk. So that is this parameters mean. So I will put them as default values in here. So but there's a required parameter called document. So I need to have a document. I have content, but before I calling this chunk document recursively function, I need to convert that into a AI document type. So for that, what I do is I define a text document. Actually, this is a text document, right? Because this MD file, I will name this as doc, and then I will go to the definition of the text document. It has a mandatory field called content. So I will add the string content to that, like this. In Ballerina, we can, since the key and value has the same name, we can remove the first one. And now I will provide the doc in here. So then I will create a variable and I will name that as chunks. So now use with this function, it will chunks the document according to the recursive strategy. So now this part is done. So now I need to do this part, generating generating embeddings using the embedding model provider and store it in the vector database. So for that, I need two components, vector database and an embedding model provider. So I will define those things first. In my connection.bell, I will define my vector database. Uh, the vector database I'm using is Ballerina Pinecone connector. I'm using the Pinecone. There's a vector database provider called Pinecone. I can show you. Yeah, this is the console of the Pinecone. This is a vector store provider, and we have a connector means library called Pinecone. So you can use this to create the vector store using Ballerina AI.pinecone. So I'm using this library. So we can resolve this module, and then I will. Sorry, this is Ballerina X. And then I will use this Pinecone and create a vector store. I will name that as Pinecone vector store. I will use the suggestion to make things easy. So now I think new. So now if I go to the vector store, Pinecone vector store, so it need two required parameters to initialize the Pinecone vector store, service URL and the API key. So in the README file, the I put a link in the chat, right? If you go to that GitHub repository, it will contain the README file, and it contains how you can obtain the Pinecone vector store service URL and the API key. The steps are there, links are there. You can go and get that, and it is entirely free. So then you can also run this and test. So for this, I will define two variables to this Pinecone service URL and Pinecone API key. So these are configurable variables because these are sensitive information, right? So I cannot show in this demo the API key I cannot show in here. It is live inside this my config.taml. I created a sample config.taml. If you need to use, like, it is something like this, and you can add that in here and API key like that in here. These are for the next demo. for this demo, you can use these two. So now I will use that. So how I got to know that those are required using this definition. So always you can go to click here and go to the definition and check what are the required things. And in the API documentation, you can see what are the required. So I will add the Pinecone service URL, Pinecone API, right? Node is correct. Yeah, service URL first and then the API key. Okay, now this part is done. Now this part is initiated. This part is done. This part is done. This part is done. Now I'm going to do this part, embedding model part. For that, I use in the WSO2 default embedding model provider. I need to import the AI. All the default embedding model provider and the WSO2 model provider are live in the Ballerina AI module. So now, so this is the embedding provider I am going to use. So I go to the definition of that. You can see WSO2 embedding provider implementation that provide embedding capabilities using WSO2 AI service. So you can use this entirely free. You don't need to generate a token or pay to get a token. So initiate this by using get embedding model provider, get embedding default embedding provider function. Okay. So if you wonder why I need use check always, it is like a throwing errors. I don't want to handle explicitly in this demo. In a real world application, you can get the errors like in here, like union error, and handle that separately. But in here, I just check and throw the error. It is some kind of similar to the Java throw syntax. Okay, now this part is also done. Embedding model. Now our building blocks are completed, right? We have data source, we have chunks, we have embedding model provider, we have vector database. Now we need to combine all of these and ingest these chunks into the knowledge base. So for now, for that, I will create we have a vector knowledge base type in our AI module. I will initiate the vector knowledge base for that. For the vector knowledge base, if you go to this type, it is represents a vector knowledge base for managing chart indexing and retrieval operation. So this vector knowledge base contain two. One is ingest and second one is retrieve. Ingest means this vector knowledge base. So if this variable, this vector knowledge base type, if like we can initiate this vector knowledge base by giving the vector store and the embedding model provider, right? So if we give this embedding model provider and the vector database, we can initiate our vector knowledge base. So it has a API called ingest. If you call the ingest, it will generate this embedding and store in the vector database. You don't need to manually handle anything. Ballerina will do that for you by just calling an API. This is the API for that. And also for retrieve, in the next diagram, if you remember, the retrieving the similar part, like get the user query and generate embedding and retrieve similar part, it has this retrieve API. So that's how simple, if you use the Ballerina for this RAG application, you can do it in one line. So I will do that in the upcoming parts in the demo. So for now, okay, I created the thing now. Then now, so I have created all the building blocks for the RAG ingest. So I have the vector database, I have the MD model provider. So I have created the vector knowledge base to do this generated embedding and store. I have chunks, I have data store. So now I will ingest my chunks into the vector database. For that, I need to simply call this function. It says undefined variable. Let's see. It is knowledge base. Okay. Okay. It will give error. It's received a chunk array, but It is because I add a union type in here. I don't need to handle errors explicitly, so I uh, throw the errors using check. So now I develop this reg ingestion part. So use so if you see this workflow, you can see that this ingest API will like the knowledge base initiate with the embedding model provider and the vector database. So the ingest API will generate the embeddings and save it in the vector database. So now let's add the print function to print function. If this is successfully, this will print. So I will tell that again. So this part is do not need to run again and again. You need to run this when your resource data sources got updated, right? If your data sources not getting update frequently, you don't need to run this again and again. Run one time is enough. Uh, but for this demo, I will put this as part in the main.bell file. In the real world application, you can create a schedule task for this and run this only if the data source got changed. Okay, now the rag ingest part is finished. Now let's move to the rag query part. So rag query means now we have the knowledge base. This part is done now. So now when user give a query, we need to retrieve the relevant documents and augment at the prompt and give to the LLM. Now let's do that part using Ballerina. For this also we need the embedding model provided, right? And we need to generate embedding and those things, and we need to augment the query, and finally we need to call to the LLM. So we need to call to the LLM. So for that I will create a connection. I use the WSO2 default model provider. WSO2 model provider. I name this as default model if you, and I use the AI get default model provider, this function. So I initiate this because in the pipeline, I need to call an LLM at some point. So I initiate the default model provider for that. Someone can ask, can't we use this one? Yeah, this has a LLM, that's correct, but that is an embedding provider. That the task of that is to generate embeddings. If you go to the API documentation of that, the source code, it has functions to embed, batch embed, like that. It does not have a APIs to chat. So it contains an LLM, but it is not relevant to the chat. But if you go to here, WSO2 model provider, it contains API to chat and generate for direct, simple, stateless LLM calls, chat for conversational type LLM calls. Okay, now our building blocks are completed. So now let's create this part, rag query part. For that, what I do is I create a new file called automation.bell, and I will add the rag query part. For that, for this use case, what I do is I create a Ballerina HTTP service. So I will just copy paste some code, and now so for create the Ballerina service, you need to have a listener. So we have a function called get default listener. So you can use this for get the default listener, or else if you need to add a customized port, you can add like this. And for this demo, I will use this default listener. So then I will define a resource function. The signature of resource function is something like this. So this is a post resource function, and the name is query, and the important thing is it accepts a user query. That means this one. So now we have the date knowledge base. Now the user query, this part is accept through this HTTP resource. So now what I need to do is I need to first embed the user query and retrieve the similar document, right? So like I said previously, our knowledge base has a field called retrieve. So if you provide the user query to here, it will automatically do the whole parts of this, generate embeddings and retrieve the similar documents from the vector database. It will do that parts. So users no need to worry about how to embed in, how to retrieve similar documents. Ballerina will then do that in a just one line. I will name this variable as context because this is the context for the user query from the vector database, right? So this is the part we need to augment it to the prompt. Like I show you in this slide, this part is the one we retrieving here. Okay, now we have the context. So what is the next step? Let's see. So yeah, what next step is augment the user query with retrieve documents. In here also, if we have the context, we need to augment that into the prompt. So let's do that. For that also, we have a very we need one line of code. We have a function called ai.augment user query. For that, if you go to the definition, it accept query match array context type and string query. So in here, I forgot to explain. So when you retrieve from the knowledge base, if you go to the retrieve definition, it says retrieve relevant chunk from the given user query from the vector store. It accepts the user query and it will return a type called query match. If you go to the query match, it consists of two fields, chunk and similarity score. That means for user query, from the vector store, we extract a relevant match for the user query, relevant chunk matching chunk for the user query, and we have the similarity score. That means how much is similar, like that. That is one, and in here augmented is also expect the query match type parameter and a user query. So we can provide this in here and user query in here. And we can create a variable for this. I will name this as augmented user message. Okay. So now this part is also completed now. Now it is augmented. So this part is completed. Now what we need to do is we need to simply call the LLM with the augmented prompt like this. Now we have generated the prompt like this with the context and the original user query. Now we need to call the LLM. So let's call the LLM. For that, since this is a direct LLM call, I will use the generate function. Previously I initiate the default model right in here. So I need to provide this augmented user message prompt. In here, if you go to this augmented type, it contains field role content name. So this content has a string union prompt. So I need to provide this content. So what I do is augment user message dot content. So this can be a union of string or prompt type. So but in here the generate is only accept a type of prompt. So what I do is I use the ensure type function in Ballerina. It will pass this augmented type content into the expected type in runtime. It is like a casting in runtime. So because of that, it will cast into prompt type and it will work. So this generate will, like I said previously, if this generate will respond the the type user given in the left hand side. If I give a record type, this will respond as a record. If I give int, it will respond as a string int. So for this use case, I will add type as string, and then I will return the response. Okay, that's it. So after you creating this, you can click this visualize button to visualize this. This is what I called the BI, the low code platform in Ballerina. Uh, so you can see the our uh, drag ingest flow in low code. It's like a diagram, step by step file read JSON, declare variable, chunk in ingest, and print. What we do in here. Sorry, in here. And also, if you go to our user query part, it will also have these things: start and retrieve, augmented user query, generate, and return. And in here, it use the knowledge base, and in here, it use the default model. So now let's run this integration, this RAG application. Same bell run. There's error in the line number 8 automation. Need to check. In here also, I need to check. That is because it is returning errors. If there's an error while retrieving, it will return an error. So I can use check to throw those errors, and there's another error, undefined variable user query. So yeah, now I can run. It given an error. It is because I think we define the connections for the embedding model provider and the WSO model provider, but we doesn't give the relevant uh, configuration for that. For give the relevant configuration for the default model providers, you need to call this VS Code action configure default WSO model provider. By running this action in the config.toml, it will create a two entries service URL and the token. So it will generated by the WSO2. So you don't need to pay or something like that. So you can use this default model providers and embedding providers using that service URL and the token. Okay, now it says it's ingested successfully into the knowledge base. Now, so this part is now done successfully. So now let's check the query part. So the query part is a HTTP service, right? So I can add a curl command, and I can ask question: who should I contact for the approval? So yeah, it will reply you should contact the department head for refund approval, especially for signature, like that. It will read this like the red flow is happen. Like it will get the relevant chunks from this document and answer you. If you ask this question from a chat GPT, like in the website chat GPT, it does not know the context, right, of this megapod company. So it will not answer like this. But since we have the knowledge base that contain the specific data resources, the knowledge about the specific company, it will answer about it will answer your questions correctly. So I can ask how many annual leaves I have. Yeah, it says you have 14 days of annual leave. And also if you go to the leave policy, it says annual 14 days. So instead of reading this whole document, we can use a RAG application to easily chat with our AI application and answer our questions. So this will helpful if you have a lot of documents, uh, policy documents, and like we do not need to read all of the things. We can just add a RAG application and do these things. This will very helpful for each and every domain in the world. So now currently we have agentic RAG and those things. So I demoed a simple basic RAG application. So you can try lot of complex scenarios using the knowledge you obtain in here. I have another demo for the agent. I will try to do that within the time limit. So since this RAG demo is over, I will clear the contents. I will put that here because maybe I need some things for the next demo. Okay. Okay, the next demo is track demo. I will quickly create a Ballerina AI. Sorry, next demo is a agent demo. I will quickly create a agent from Ballerina. So this will be very helpful to you in order to do your things in future. I mean, not for the hackathon, not only for the hackathon, not only for the exam, but if you want to do some like automating things, like sending emails or reading some things, like if you are a person who like to do research, PhD or something like that, you can retrieve research papers from an online site and summarize, and like those things you can do using agent and also using RAG, combining both. So these concepts will help for you in future. So in Ballerina you can easily implement that, and also you can use a free token, right? Like I mean freely you can implement without spending money. So it will helpful for you. So I will start the agent demo now. For that, what I'm going to do is this for this one, my use case is I'm developing a personal AI assistant. So personal AI assistant means it's like I have assistant, not a real one, AI assistant. So when I need to send an email to someone, or uh, I need to list my emails or summarize my emails. Like I can use this person AI assistant, or I can create an calendar event, find my calendar event, what are the busy dates, like I mean, what are the available free slots I have, like that. Now going to create an agent like that for do those things, personal AI assistant. So I will start the coding. So so okay, I will start in the AI agent, sorry, agent.bat file. First of all, I need to show you about the Ballerina agent type. So I will import the Ballerina. So, Ballerina has a type called AI agent. So if I go to this AI agent, you can see that there is function called run. It needs a query and it needs a session ID. I will explain those things. So the most important thing is for the agent, when you initialize in the Ballerina agent, it needs agent configuration. If we go to the agent configuration, it needs a system prompt, model, tools, memory. These two are not very much relevant to this demo. So I will explain you what are those by my slide. It is like, okay, this slide. I tell you agent need tool, brain, memory, right? So this is the tools array. We need tools. So our agent, for initializing the agent, we need tools and we need memory in here. In default, it will use the in memory. So if you need memory, you can use that. We need tools. Default, it is empty. And the brain. Brain is this one, LLM, the model provider. This is the brain of the agent, and tools and memory. And this is a system prompt. This is system prompt is the thing we instruct the agent what you need to do. Like if it is a personal AI assistant, it need I am instructing it to say you are a personal AI assistant, like that. Okay. So that is the AI agent type. So I will now create an agent. I will name that as personal assistant. Well, check new. Okay. Now I need to fill the building blocks to create a AI agent. So brain, tools, and memory. Those are the building blocks I need to get to build the agent. For this case, I will use the default memory in the type in here the default memory provides in memory chat like that. So I don't care about the memory in for this demo. So I will care about the tools and the system prompt and the brain, and that means model LLM. So I will initialize tool as empty array for now. In the system prompt, there are two fields, role and instructions. Role means what is the role of the AI agent. So for my use case, it is a personal AI assistant. And I need to give instruction for my assistant what it need to do. So I will copy paste the instructions and I will explain. Okay. So this is my instruction. So it says you are Nova, a smart AI assistant, helping me to stay organized and efficient. So your primary responsibilities include calendar management, email assistant, context awareness, provide like that. So I will instruct the AI agent saying that you are my personal assistant. So I expertise the role of the AI agent. Then I will tell the agent that what it need to do: calendar management, email assistant, context awareness, and also I provide some guidelines in the system prompt saying respond natural, friendly, professional tone. Always confirm before making changes. Like prioritize clarity, efficiency. Like that, I can give instructions to the agent. So these are the instruction that AI agent follow in order to do action or give a response. So that is my system prompt. So I use tools empty for now. Then I need to define model, the brain of the thing. So for that, I'm creating W0 model provider. The same way I did in the previous demo. This way. Okay. Now I will provide this model in. Now our agent is completed. Uh, not not fully completed, right? Because I didn't add any tools. Other parts are okay. Brain is now created. System prompt is now created. So now let's create some tools to add into the agent. So because of the time constraints, I will copy paste the code in here. So I will create a Ballerina function. This function, we can use this function to list unread emails. For that, I will use the Ballerina Gmail connector. Ballerina X. I will use this connector. So this is the first tool I'm going to say. I add some log statement. So I import the log module as well. So this is the Ballerina function I'm going to use as a tool. So what it does is it lists the unread emails in my inbox. So it accept nothing and it go to my email email box and get the messages by filtering is unread filter and return that list the unread email. For that I need to actually initialize the client Gmail client. So I will do that. For this use case, for initializing the client, you need to have the client ID, client secret, and refresh token of the Gmail. Like you need to obtain that from going to the Google console and log into that and do that. So in the provided GitHub repository in the chat, the message I put. So I give you the links that you need to go and get the refresh token and client ID secret. So if you have any troubles, you can ask any LLM, ChatGPT or Gemini, they will instruct you, like they know how to do that. So they will tell you how to do that. So you can get this refresh token, client ID, and client secret to create a Gmail client. So with these credentials, this Gmail client is created to the my account. So I can use the Gmail client to do things in my account. So things uh, these things are defined in the config.bal file as configurable variables. So it will store the real values I store in the config.taml in this manner as a sample configuration, this manner. Uh, so okay. So yeah, I define this function. So what this function do is list the unread emails uh, in my email box. So I will add a comment, documentation comment. This will help the AI agent to see what is happening inside this function. So now I need to convert this function as a tool to the agent. For that, what we can do is we can simply add this annotation. We can add simply sorry this yeah, we can simply add this annotation. With this annotation, user do not need to do anything. This will identify as a tool for the agent. So then I will add this annotation as well for our graphical view. And so now this is a tool. This function is a tool because I add this annotation. So I can add this into this tool list. So now this agent contain a one tool. It can do list unread. It can list the unread email message. So like similar wise, I will add some few tools. Those means functions, Ballerina functions that can use to agent to perform actions. So my second tool is to read specific email from my mailbox. It reads a specific email. So likewise, I add some few tools. The third one, get email by label ID. The complete code is in the GitHub repository. You can find. And the fourth one is for send email. This is also a tool that AI agent can use. I will add this tool to the AI agent. Like this. Like this. So now our agent contains the brain, tools, and system prompt. Now it can use those things to work together. Now let's so if I go to the slides, I told you we have two type of agents, chat agents and inline agent. Chat agents are exposed through HTTP endpoint REST service and ideal for chatbot-like experience. So I am in this demo, I will create a chat agent. So because of that, I will expose this as a HTTP service. I just copy paste the code. So in the my agent name is personal assistant. So in here I will we can execute the agent using the personal assistant dot run method. So this HTTP service has one resource function called chat, and it has a payload of request message, a request message. It has a session ID and a message. This will automatically handled by the Ballerina BI interface, or else you can handle that. I will show you how it works with the chat interface. Or else you can use this as an inline agent also, or else like if you need to run this agent, you can just invoke the run method with the query and the session ID. So now I will expose this as a HTTP service and request and run like this. So now I will visualize this using the BI Ballerina integrator. Now this is the visual view of this agent. It contains the system prompt and it contains the WSO default model provider and it contains the set of tools like this. So similar to the previous demo, since I am using the WSO default model provider, I need to execute this VS Code command configure default WSO model provider. Then it will execute and add the WSO default model provider configuration values to the config.taml in order to run the application. Okay, now let's use our chat agent. Uh, we need to first uh, I need to chat with this agent. So I click this chat button in the visualize. This is the BI view. There are compilation errors. Agent must be marked as final in the agents.bal file. Can mark this as final and this can also be final. Okay, now let's visualize. So this will create a chat interface for our agent. I will show you how it works. You know, the chat interface got created. So I will ask what is your name. In it is says its name is Nova because in the system prompt I said you are Nova, so it knows it name is Nova. So I will ask what are the things you can do. It can use calendar management, email assistance, privacy and security. So the things we specify in the system prompt, it says it can do. So I will tell is the most recent unread email. Summarize. It says there's a mail and like that you can now I will, so you can see there's a logs are there. So yeah, so in our agents it use these two tools, read the specific email tool and this tool. So now I will show you one more send in email part. We can use this to send email as well, this agent to send emails. I will tell I need to This is my personal email to like this. Uh, it will get the confirmation and chat. Yeah, it will get the confirm. And if I say yes, it will send the email to me. Yeah, the email is successfully sent. I cannot show the email inbox now, but if you try this one, it will show the email is successfully sent to the email. So that is how this agent work, and that is how this agent execute the actions. Yeah, that is the demo. So you can also generate chat agents like this using simple Ballerina, simple like minimum number of lines of codes in Ballerina. Like I think it use only less than 10 code. I mean for agent we need this system prompt is the lengthy one. Others are very small. Connectors are also we can use the inbuilt Ballerina Gmail connector like that. That's all for the demonstration. We'll go to the slide. Yeah, okay. I think you can see the slide now. So, yeah. So if you have any question, you can ask. So if you have doubt regarding the demonstration process, you can check the GitHub repository I provided. Like when you check again, you will understand if you have some questions, and you can ask the recording also. Since this is the AI is the hottest topic in the current software domain now, this knowledge will, I mean, this knowledge and the things you observe in future will help you to like find jobs and like those things, because AI is the current trend. Almost uh, all the offices, companies in the world now migrate into the AI parts. I mean, it's not like training models, but using these GenAI applications, LLMs to improve the quality of their product. And so this is the current trend: AI agent, RAG applications, and MCV. So you can, if you got the basic idea in here, you can explore those things. If you didn't got the basic idea, you can ask the recording in your free time. uh, and also that please check the demo as well. It will create a some kind of a powerful application, two powerful applications: chat agent and a rag application. So if you have any questions, please raise now. You can use the chat also. Mm. So regarding the learning resources, you can you can go to the, I think you know about this because you participated to the previous sessions. So we have a learn guide and Elna by example guide and YouTube training series. And also we have community channels, Stack Overflow, Discord, Twitter, like that. And we have a Ballerina student program, student engagement program, and a Ballerina ambassador program. And you can also participate into those things. Okay, thank you.
It seems there are no questions at the moment, so I think we can move on. What an enlightening and engaging session this has been. On behalf of the IEEE Student Branch and the IEEE Computer Society Student Branch chapter of the University of Moratuwa, we extend our heartfelt thanks to Mr. Sasindu Alahakoon for sharing his valuable insights with us today. We deeply appreciate the time and the expertise you have dedicated to this session. Your guidance has broadened our understanding of the AI capabilities in Ballerina and inspired us to think about innovative applications for the future. As a gesture of our gratitude, we would now like to present you with a token of appreciation in recognition of your invaluable contribution to this workshop and for inspiring our participants on their journey ahead. Once again, thank you, Mr. Sasindu Alahakoon, for those inspiring insights and for sharing your expertise with such clarity and passion. Before we conclude, a quick but important reminder for all our participants. If you haven't submitted your project idea yet, there are only 8 days left. The deadline is on the 19th of August at 11:59 p.m. So be quick, finalize your concept and get it submitted as soon as possible. Don't miss your chance to make an impact. Also, don't forget to take advantage of all the support materials that will be shared after today's workshop. They'll help you reinforce everything you've learned and assist you in building a stronger solution. Now, to celebrate today's gathering, let's take a virtual group photo. If you are comfortable, please turn on your cameras so we can capture this moment together. Okay, I hope everyone's ready. We'll have a countdown. 3, 2, 1. Okay, thank you everyone. And just like that, we've reached the end of today's session. Thank you for being part of Workshop 2 of Innovate with Ballerina 2025. I'm Senaya Bandara and it's been an absolute pleasure guiding you through this session. Until we meet again, stay creative, stay bold, and most of all, keep innovating. Good night.